Our next speakers are Dr. Thomas Novicki and Jahna Voigt from Marshfield Laboratories, and they are going to talk to us and lead us through the discussion on the MALDI-TOF instruments. So I will let them take it away.
All right. Thanks for coming today. We're going to do a tag team here, and we haven't rehearsed it, so wish us luck. So yeah, we're going to talk about the use of the MALDI-TOF, and I kind of alluded to this in my question is, how do we validate it? To me, because I've been doing this quite a while, and I started out and we had one of the first Vitecs. It actually had a McDonnell Douglas, a little swoopy thing, because it was a partnership with McDonnell Douglas and bioMérieux. But we still did a lot of API strips and a lot of biochemicals, and then it became more and more reliant on the automated ID system, and a lot of those kind of biochemicals went away. But we were still doing them, and we saw that with the printout from the Vitec is, it says, well, if you can't discriminate, here's the biochemicals to do, and you do them. And with the mass spec, it's a totally different story. I can say in our experience, we had been doing 16S sequencing for a while, and in some ways, that was similar. The results you get and how you use those results were similar to how you deal with MALDI results, because you still, with the 16S, you have to validate the results. And we don't have many biochemicals in the laboratory anymore. So how do we deal with this? And that's what we're going to tell you about today. So we're going to talk about MALDI-TOF spectrometry in a time of mu lambda testing. So well, what does that mean? Well, Aaron.
Pointed at there's an antenna that's, no, I'm sorry, it's like right there.
You got to push it kind of hard too.
Sorry about that.
Next, right? Yeah.
Sometimes it gets off on the screen, so here you go.
So I get a point right there. Yeah. Okay, well, so mu, the Greek letter mu is used to designate micro. Lambda is wave, so mu lambda is the microwave. And this guy here, he's still a happy camper, but we're melting him real quick. Okay, so we have no disclosures. We're just doing our thing, microbiology. So, I'm going to kind of start out and talk about, what's different and what's changed. Now, you look at these guys here, all in the late 1800s, so many things happened in microbiology and medicine in general. And this is actually, this wasn't our unit here, but we had one of these. And if you look closely, you'd see the little McDonnell Douglas swoop, because as many of you know, I think, those of us of a certain age, the original Vitec was created for use on a space station that NASA was planning. I don't think that ever came to fruition, and the partnership broke off, and bioMérieux took the Vitec instrument and ran with it. But so many things happened, and if you think about it, what these people were doing, and even the development of the Vitec was, how do we make these things that are academic microbiology activities, how does it fit into the workflow of the microbiology, the clinical microbiology lab? Because we can't be doing research type stuff in most of our labs. But as I was kind of alluding to, up until even very recently with our biochemicals is, things really, up until recently with the MALDI-TOF, things didn't change. And I just love to, put these two pictures in juxtaposition. I've used them before. It's a lot of the same stuff, but the MALDI was a game changer. And so let me ask you this: how many labs do you have? How many have a MALDI-TOF? Really? Okay, in your lab. Okay, and then of those that don't, like we were talking about, going to your home lab, have access to a MALDI-TOF. You know what I mean? So a couple, okay, yeah. Okay, so it's not such new stuff anymore. And so at this point, we're going to hand it over to Jahna, and we're just, here's the mouthful. Why do we call it MALDI-TOF? And we're going to talk about the principles of it a little bit.
Okay, so MALDI-TOF stands for Matrix-Assisted Laser Desorption Ionization Time-of-Flight Mass Spectrometry. There are 2 FDA-cleared instruments of this type, the bioMérieux Vitek MS, and then the Bruker MALDI biotyper. There's their current taxa as of 3/3/2023. As a quick overview of the technology, the laser matrix is overlaid on the cell that you spot, the laser hits it, desorption and ionization occurs at the same time. The molecules, they shoot up the flight tube, and it is the mass to charge ratio that is measured as it travels up the flight tube that provides a spectrogram. The large spectrogram peaks, that is what the mass spec is comparing against its known database, and the little peaks are kind of just like background noise and other types of proteins that are detected. This is the targets, the ribosome. It's just a nice picture. As for target plates, Bruker comes with a 48 and a 96 spot, whereas the Vitek has a 64 spot slide. On the left there you have your Bruker MALDI, and on the right is our own Vitek. Advantages to the mass spec are they are time saving. You can read spots and sometimes entire slides in less than half an hour. It really does not require very much biomass. We spot using a single colony. Cost per test is much cheaper than using biochemical IDs. It's pennies per reaction. And it is a highly accurate test. Disadvantages with the mass spec is that it can only perform identifications, unlike the Vitek 2 system, which could do susceptibilities and IDs. And because it is a separate instrument, it does require a complex integration system. Limitations associated with the MALDI is the growth of colony, depending on how your colony is, if it's really mucoid or if it's particularly crunchy. How well it spots is going to affect the success of the identification. There's a limit to what the MALDI can differentiate. This really comes down to like organism complexes, as were previously mentioned with other technologies. It does struggle with that. And then it also has a hard time differentiating very close IDs. We see this particularly with our staph intermedius group and staph pseudo-intermedius. Also, the knowledge base is finite. The Vitek MS has 1,300 organisms, 400 of those are FDA cleared. Bruker does have a larger database with their RUO, and 488 of those are cleared. Potential errors associated with the mass spec technology is it is very technique dependent. How you apply your spot, how you apply your matrix, getting it onto the right spot, programming it into the computer, there's a lot of technical error that is possible. The type of specimen you have, we use our mass spec for a lot of blood culture isolates. If there is a large amount of blood on the spot that you're putting it on, that's going to inhibit its ability to detect the bacterial ribosomes. Arbitrary identifications, as we have discussed a lot today, sometimes you just get weird IDs on your mass spec. And it does generate complacency, as we have seen. So when I say that, I mean that a lot of times it's very easy to just look at your culture, spot things on the mass spec, and then finalize it as is. But what we really hope for is kind of like an always going circle. You look at your culture, you perform your spot testing, you get your mass spec ID, and then you go back and you reconsider everything you had already done. Does your mass spec ID correlate to the way the culture is presenting? Do those IDs match those basic biochems that you performed? I call this my microbiological Ouroboros. Sorry. In our lab specifically, we attempt to minimize complacency through a few specific methods. In our work card, the most important part, if we're going to spot something on the mass spec, is that we detail the colony description in the work card. We will say, like, is it irregular? How large is it? The color? Anything so that whoever's going back can look at it and be like, does this match what I am getting or what somebody else put on? We decide if a MALDI is even necessary. If the culture type is not significant, like blood versus a leg swab, for example, you may not even need to go to the MALDI. You can ID things like coagulase negative staph using biochems. You may not even need that full species level identification. And then we also do offer ID upon request too. So like if a physician determines that they want a more specific ID, they can always call us back and then we can go and utilize those more advanced technologies. We do treat our initial culture evaluation as a safety measure. We always look at our plates before we go in, not just for looking for things like maybe molds that are growing, but also those suspicious colonies that might make you worried. You might want to go into the BSL-3 or a biosafety level 2 cabinet, for example. We do employ a lot of rapid identification if possible with our Proteus mirabilis, our Staph aureus, and Pseudomonas aeruginosa especially. And in a way, the preliminary testing that you do before you spot on the MALDI can then turn around and become your confirmatory testing. You do that indole on your E. coli, you get that E. coli result back on the mass spec, and you go, yep, it was positive, I'm content with this ID. So I've put together a couple case studies from experiences that we've had within the past year or so at our lab. For the first case study, we have an aerobic anaerobe. As a background, we had a new patient blood culture. The anaerobe bottle went positive first, so per our procedure, we subculture anaerobically and aerobically. Gram stain was gram-negative bacilli. We also have a BCI, the BioFire BCID panel at our lab, so we utilize that, and we did not get an ID. So our backup ID method is the MALDI-TOF. Using our aerobic subculture growth at 24 hours, we got an ID of 99.9% Prevotella oris. And now I have a question. So the answer for this one is no. Our immediate issue here is that Prevotella is an obligate anaerobe. We wouldn't anticipate it to grow on our aerobic subculture. How about anaerobically? We incubate our anaerobic cultures for 48 hours before we look at them. So the following day, we noted that it was growing just as well anaerobically as it had been aerobically. It had the same gram stain reaction, and when we spotted it on the MALDI and then repeated it, we got 99.9% Prevotella oris again. That question. Yes. That is exactly what we did. We performed additional biochemical testing. The cultures, the MALDI-TOF, it does come back. It is appropriate, but it still doesn't make sense. That organism should not be growing on our aerobic subculture. So aerobically, we performed an APNA gram stain confirmation, which uses aminopeptidase. The presence of it creates a color change. Ironically enough, if there is a color change, the positive reaction implies a gram-negative organism, whereas a no color change or a negative reaction is a gram-positive organism. So we had no color change. So this brings new problems to us. This is implying that our organism is actually a gram-positive, even though we gram-stained it multiple times as gram-negative. And then also, in order for us to trust this, we have to assume that this is actually an aerobe, because this is not a validated test for anaerobic organisms. So we did try to get an ANC card. We normally wouldn't have gone this direction if we were truly suspecting a gram-negative bacilli. We usually use this for anaerobic gram-positives, but the card did not work. So anaerobically, they set up potency discs. We expected it to be sensitive to bile, variable with colistin, kanamycin, and vancomycin resistant, but we got the exact opposite. So at the very least, we've officially ruled out our Prevotella. In the end, we did send it out to Mayo, and we came back with an identification of Paenibacillus etheri. That's very different from a Prevotella oris, but it does correlate with a lot of the manual testing that we performed. It is a gram-positive rod. It is a facultative anaerobe, so it growing anaerobically was not a surprise. It does decolorize quite rapidly, and it is not in the Vitek MS database or a list of available organisms on the ANC card, so it never would have been identified through those methods anyway. For our second case study, I have a strange Pseudomonas aeruginosa. This is also based off of a blood culture. This was in a new patient's aerobic blood bottle. The gram stain had gram-negative bacilli, and again, our biofire did not come back with a usable ID. So we did our rapid method with our MALDI-TOF. We did it on 3-hour growth, and it came back with no ID. So it was set aside until we obtained reasonable growth at 16 to 24 hours. With adequate growth, close macroscopic examination showed that we actually had a mixed culture, which explains why our rapid MALDI-TOF ID did not succeed. One morphology was appropriately identified as an Acinetobacter yersingii. The other was small, gray, wrinkled, and had like a concentric circle pattern. And it was MALDI'd as a Pseudomonas aeruginosa. What do you suppose are the issues with this so far? Yes. We were already concerned with this because the biofire did not pick out a Pseudomonas aeruginosa, which is a major pathogen that is available on the panel. The Vitek says that there is a Pseudomonas aeruginosa, and although colony growth isn't always the best way to determine if something's truly an organism or not, it was a strange morphology. So to attempt to resolve this, we did set up a GNI card, and it came up with a low discrimination split ID of Pseudomonas aeruginosa fluorescens and Stutzeri, with many discrepant chemical reactions. Too many things were not adding up. We were confident with our Pseudomonas genus, the oxidase, all of our basic biochems did match, but this was a blood culture, so we sent it out for further identification. In the end, it came back as Pseudomonas nitroreducens. Again, this organism is not available on the Vitek MS or on the GNI card, so those methods never would have gotten us a successful ID. And we really only did go this far because it was a sterile site. Had this been perhaps like a surface level wound, we wouldn't have needed to go to the species because genus is quite sufficient. And finally, I have a case study related specifically to me and my time in training. I was working on a foot tissue culture that was growing numerous gray non-hemolytic colonies. My colony presentation, I immediately thought of Enterococcus species. All my benchtop tests correlated, including my PYR, which was positive. When I gave the culture to my reviewer to examine, he came back and said that it was a Strep A galactiae. And he had a positive latex test, and those aren't very similar. So I panicked. Did I miss maybe like some faint hemolysis, although it's not impossible for them to be non-hemolytic? Was it actually not a positive PYR? Sometimes group B strep gives you that weird pale pink. And then what does the MALDI say about it? And it came back with a 50-50 Enterococcus faecalis strep A galactiae. So that was exciting. What would you do next? Oh, I gotta make it so you can guess or answer. So these are all pretty valid options. We've already got a strange MALDI ID, so repeating it certainly wouldn't hurt. Instrument limitations, there are some things with beta hemolytic streps that the Vitek doesn't really like. There are, however, no limitations associated with Enterococcus and strep A galactiae. As for repeating biochemicals, we do have very discrepant results, so it would make sense to repeat those. But at the time, we had opted to examine the plate with our stereoscope. Let me hide that. Using the stereoscope, we saw one non-hemolytic gray colony and one slightly lighter gray non-hemolytic colony. So isolating both of those out, whoa, we're not ready for that. Whoa, sorry. So using those isolated colonies, we were able to get a consistent PYR positive Enterococcus faecalis subculture and a consistent PYR negative strep B latex positive Streptococcus A galactiae culture. And in this instance, if it weren't for the MALDI, we may not have gone that far. So I like this case study too because it showed that the MALDI was working with us and not necessarily against us. So closing thoughts that I have is that you can never be too careful when you're doing your initial plate examination. That's like the most important part of microbiology. And in clinical lab, mass spectrometry should be treated as a tool that is tantamount to your basic biochems. You want to use it with your culture examination, not in place of. So you still do want to scrutinize that test result. It is still a very reliable technology. And it really is up to you, the tech, to decide what you do with that identification. If you don't like it, you can certainly take that as far as you need to feel comfortable.
All right, thanks. So for the closing part of our talk here, I'm going to talk about our experience with MALDI-TOF as a whole. It's not necessarily directly related with critical thinking, but it still helps us in the process of getting to the right information. So here's what I mean. We started out with the Bruker MALDI-TOF 10 years ago probably. And we tied it into the Trek sensititer system, which is not, I think, what's the norm, because of course, you got your MALDI-TOF giving you your ID, you need to connect it to a susceptibility test instrument. And as I think most people probably end up doing that with a Phoenix or a microscan. Feel free to correct me on that. The Trek was never a very popular instrument. There's probably good reasons for it. We chose it because at the time we were doing a very extensive veterinary microbiology, and they had a number of susceptibility panels with the veterinary drugs on it that are not used in the human world. So we made the choice, and the way that was set up was that, and I think this is the model still, but I will add the disclaimer that I'm not extremely familiar with where Bruker is right now with their integration of their ID with susceptibility instruments. But at the time, it kind of fell, not kind of, it did fall upon the manufacturer of the susceptibility instrument, in this case Trek, with maintaining that interface. And I'll tell you, I developed a really great respect for what goes on in a Vitek or a microscan walk-away or a Phoenix. And what I mean by that is the integration of the ID data with the susceptibility data in an accurate, consistent, reliable way to get your susceptibility interpretations. And so, so we found, so it was the manufacturer, Trek, now Thermo Fisher, who maintained that interface pretty well. But it was not unusual in our experience, probably a couple times a year, that we'd have some serious problems. Sometimes it was hardware related. There'd be a change in, either the Vitek, I'm sorry, the sensitizer versus the MALDI-TOF, or it was a change in nomenclature, a database to get updated, they didn't match, and so that would cause some frustration for us. Let me see what I got on my next slide here. Yeah, and so this kind of, is the depiction of the way the data flows, and certainly, like I say, if there's something different on the horizon now with the way the Bruker instrument works, please feel free to say so. But you have the Biotyper, Sirius, and I guess it's the name now, CA, and it's connected through a point-to-point network, or maybe over your network, your system network, and then the data is put together and gets a susceptibility result, and the ID and susceptibility are passed on. That's the way our interface was hooked. So there was no direct connection in this direction to send the ID and then bring the ID back down here. So this is not here. Instead, the ID goes this direction and comes down here, and then it's put together and you get the susceptibility. We actually tried to build that to get away from this situation here, and it didn't work. Okay. So this is what I just explained, is we tried to build this. ID goes up, ID comes back down, susceptibility goes up, the data are married in the culture report, and we couldn't make it work. And at the time we had a very robust, because at the time we were developing all of our software above the desktop, and we had a really experienced interface programmer, and he couldn't make that work. So we were really, to the end, we were faced with this kind of a situation, and a couple times a year, that one electron gap would kind of fail us. I should say is that we were very happy with the Bruker MALDI-TOF, and it was more on the Thermo Fisher side when we did away with our veterinary lab services. We looked at a better option. So, I think the pros of this setup are obviously is, people have their preferences. Do you like the microscan and, very much the broth microdilution, the ability to look at the plates? The Phoenix offers a lot of option. We did have a Phoenix at one time, and it was a good system. But to me, the cons, and they're very serious ones, are here is that point-to-point connection and interfacing. Now, let me ask you this: is anybody interfacing at this point their MALD? So if you have a Bruker, are you interfacing it with a Vitek? Yeah, no, okay. Theoretically, it can happen. There was one small kind of a startup company that had a middleware that said it could work. They wouldn't give us any guarantees because we did consider it. So getting a Vitek 2 for the susceptibility, and then stick with the Bruker. And this, we were looking, we knew we had to get rid of the Trek system because it was just expensive and it was ultra unreliable. And so we were weighing our options. Was it going to be, Bruker and a Microscan, Bruker and a Phoenix, or were we going to go, the bioMérieux way? Well, we drank the bioMérieux Kool-Aid, and It's pretty good Kool-Aid though, let me tell you. You know, cherry, you know, full amount of sugar. And so what I mean by that is what bMRU has done, and for the bMRU users in the audience here will understand this, is that they have really focused on integration through their intelligent middleware, MILA. And so the way that works is it all uses your hospital network. And the only thing that is really, you know, of the bMRU pieces, you know, so you get the Vitek mass spec, you get the Vitek 2, throw in your blood, your bMRU BacT-Alert, and those all are connected to MILA. MILA, and through your network. MILA then is connected, that's what's interfaced to your LIS. And so basically the MILA is just really integrating all of this data. So it's almost like, you know, what goes on in a Vitek 2 or a Microscan or a Phoenix is taking those ID and susceptibility data and really, you know, seamlessly merging them and in a unified, reliable way. Is like, you know, it's now they're in separate boxes, the Vitek mass spec and the Vitek 2, and MILA is doing the unification. MILA offers some other capabilities as well. It has some reporting capability. I understand that there's going to be a new version. I think they're going to change the name too, that is going to have more robust reporting potential. Another real value is that your tech workstations can be used through a browser connection to MILA to set up your mass spec run, to set up your AST run. So it's very useful in a workflow kind of a manner and working lean because the tech is doing it right at their computer screen. Open up your browser, log on to MILA, set up your mass spec run, you set up your susceptibility run. And I think, you know, we were looking at it, Bruker was offering some kind of solutions like that, but I don't think they were really as well developed. So in the end, we ended up obviously deciding on the Vitek system, and I can say that in our experience, it's been in very good. The whole connectivity issue that we would, you know, experience every so often, it hasn't gone away, but it's more related to like computer, you know, hospital, on the hospital side. It's not through the connection between the ID and the mass, you know, the mass spec and the Vitek 2. So it's not 100%, but as far as that integration of the ID and susceptibility data, it just works very well. So we've been very happy with it. One other thing that they offer that we didn't take advantage of, and I don't know if they still offer this, but they have an ability to the system that will data mine and actually pull data out of, you know, the LIS, other information and robust, you know, data mining tools. Does anybody who has the Vitek system, does anybody use that? Is that ringing a bells? Anybody? They wanted to sell it to us. It was about 20 or 30,000, and we just, you know, said no thanks at that point. But okay, so yeah, we're very happy with it, and I would say from our experience too, we were using the Bruker RUO database. And when we switched to the Vitek, our compliance folks said, you know, you really can't be turning out and billing with the RUO. You got to use the FDA database. And as you know, so the way the Vitek mass spec works is you have claimed organisms and unclaimed organisms. So you still, from what I understand, it's not the full fat Vitek RUO database, which is apparently you can purchase. I'm not even sure if they'll sell it to a clinical lab. So but you have this added, you know, a group of unclaimed organisms, and I'm told by the BMRU folks that those unclaimed IDs are still pretty well validated. They just didn't go through the clinical trials that the FDA requires. That said, we found with the Bruker that it was very often, got us the answer we needed, where the way that at least our salesperson and our field application specialist explained it is to, BMRU intends, as far as ID goes, is that, yes, use the mass spec, but as a backup, use the ID cards. So it's more meant to be, if you didn't get an ID on the mass spec, it's not in the database, it might be in the ID, card database. So that was a switch for us, because when we had the TREC system, well, we never used the ID system on that. How are we doing on time? About time?
Yeah, pretty quick if we want some discussion.
Wrap it up. Yep. So, yeah, and I'd be happy to talk about that, at the end. Here's the pros. Again, I've already touched on all these points. Of course, one of the cons is it's, you're married to BMRU, and like it or not. And so that's it. Yeah.
So who has questions or who has comments, stories to tell about their MALDI, using the MALDI and issues with it? All right.
Ray Podzorsky. I'll just say, a couple of years ago with the BCID, we did run across a Pseudomonas that it wouldn't identify. The blood culture went positive and the BCID was negative, grew it out. It looked like a Pseudomonas, smelled like a Pseudomonas, biofired, on the MALDI, a Pseudomonas aeruginosa, and sent it out to a reference laboratory, came back as Pseudomonas aeruginosa. So then we got BMRU involved, and it disappeared for a couple of months, and then a letter showed up that said, our primers don't work on this Pseudomonas aeruginosa. And that was the end of the investigation.
Yeah, goodbye and good luck. Yeah, back in when I was new at this and considerably less jaded than I am now, I would diligently send those isolates off, and then you get the letter back and they say either cannot replicate or, yeah, they did, but, it happens. So I don't do that so often anymore. I would like to ask, if someone who is using Bruker and Phoenix or Bruker and Microscan, if you could be willing to, just validate that what I explained with our, back then is still the situation now as far as integration, or do they have a better middleware that as an option? Does anybody speak to that, or?
Hi, Haley at WDL. We utilize the Phoenix M50s for our susceptibilities and the Bruker MALDI for ID, and we use, it's called Epicenter, that serves as like an intermediate for us. Mm-hmm. Both feed into the Epicenter database, and then our LIS pulls the ID and susceptibilities out of that then.
So you are connecting your Bruker to Epicenter?
Yep.
Yeah, and who supports that interface? Is it Bruker or
it is BD.
Yeah. And have they gotten better at, that? Because that's where our problem would be is, Bruker would change something and, in an update date, and then it would come over and they didn't tell, Trek, and they didn't, make the changes necessary, and then we'd just be, beating our heads again.
We do have one of our supervisors who is heavily involved with all of the Epicenter side of the stuff, and she does a really good job of making sure that when updates happen on one side, they're happening concurrently. So we haven't had any issues since that, really, with her overseeing all of our updates and everything, we haven't had issues with like a huge library update from the Bruker side, and then like Epicenter doesn't understand what's happening. We most of the time don't have issues with it. It's only when there's like a brand new nomenclature change that Bruker did, and then we don't have it on the BD side, but usually those are like happening before we even know about the nomenclature change, so that's the only time we really run into issues with it.
Yeah. So, yeah, I mean, that's an interesting contrast, I would say, then, is with, you know, with the, you know, the Bruker and whatever your system is like, you need to know, you know, that, how that integrates very well. I would say if you go with Mila, it's what they call virtual Mila, which means it's running on your organization server, and that's a whole nother world of pain, potentially, because now you're dealing with IT and security, and so, you know, it's another skill set that you need to work with that system, is how to work with IS, which is often very painful.
Thank you, other thoughts, Tim?
Oh, he's gonna.
I just have two questions, or a clarification. So you went from using Bruker and Sensititer to using the bioMérieux and the Vitek too? Okay.
Yes.
Okay.
Vitek mass spec.
Did you see a increase, because if I recall correctly, the Vitek mass spec has a smaller database. Did you see an increase in the number that you couldn't get identified? And forgive me if you touched on that.
You didn't use Bruker, did you? No.
Nice try.
Yeah, Jahna's, yeah, showing my age. Yeah, so, well, yeah, and that's, I did kind of, I think, maybe I didn't, I wasn't clear because I was talking fast, but we were using the Bruker RUO, you know, and we did a lot of validations. We were, you know, luckily we had some resources that, you know, we ran just a load of all different kinds of organisms. So we did a validation ourselves. And then, you know, but it's like kind of comparing apples and oranges, because when we went to the Vitek mass spec, we went to the FDA cleared. And again, it does have a subset, or, you know, an additional set of unclaimed organisms that, you know, the company says are very, very well validated. They just didn't do the clinical trial with it, you know, that the FDA required. But that said, I do think, I mean, it's not unusual. My sense is that, and particularly because we had sequencing at that time, you know, so if we got something that was odd on the Bruker, you know, it didn't make sense, we'd sequence it. It was very rock solid, you know, and one thing I always said about the Bruker, my feeling again, you know, just anecdotally, was that if it didn't know, it would tell you it didn't know. And I think, but again, this is just, you know, if you read the papers, they're comparable, but my gut feeling is that we see more, not a lot, but missteps, like the ones, you know, some of the ones that Jahna presented that are just real head scratchers with the mass spec. That's, you know, that's my feeling. But then again, you know, another thing is we don't have the sequencing anymore. Now, some of them are obviously, you know, pain bacillus, Prevotella, you know, but.
I have one other question, I'm sorry, and I know that Dr. Beck kind of alluded to this before too, but I think you mentioned it, that you kind of use your microscan, or your Vitek ID as a backup to the MALDI. Are there ever, and that seemed, to me, I know when he said it too, I thought, well, that's kind of weird, because I, you know, think just the opposite, that the MALDI is kind of more of a gold standard. Has there ever been a situation where you've gotten discrepant identifications and actually used the Vitek ID, or do you always do additional work on them, send them out for sequencing or something like that?
I would say before, when we're working a little bit more with our non-validated IDs right now, so we're kind of making a procedure so that we're more readily available to use those. But oftentimes, if we would get a non-validated ID, specifically a gram-negative rod, we would use our GNI card in hopes that we would get the same like high percentage ID, so then we could use that. So it was more like we got a good ID, but we can't really use it, so let's try to get it in a different manner. Would you?
We would, yes, we would use the Vitek ID card to validate.
Yeah, the non-validated.
Unclaimed, yeah. I think again, it's my gut feeling because I'm not, out there on the bench working every day, but my kind of feeling is that, the databases of the two ID systems, it's like the Venn diagram, there's a lot of overlap. Yeah, it's both going to call an E. coli and E. coli and Staph aureus, but then, you got some things, particularly if you're thinking about the Vitek mass spec with the unclaimed as well as claimed IDs. Some of them are not in the GNI database. So the IDs from the Vitek are pretty good. It's not a totally faulty system. So, we get a no ID on the mass spec and say, well, let's try the GNI, or another, gram negative, or another Vitek ID card. So that's what I mean. We use them in a complementary way. We don't get ID for one, we'll do the other, and then, validate it like we're talking about today.
Okay, I have a question, and I'm going to kind of change the topic, but stay within MALDI. One of the issues with MALDI is that's known, and thank you, Alana, for your first case study on this, is that it will often misidentify those bioterrorism select agent types of organisms. And the problem is that you won't necessarily even know that you've got that bioterrorism agent because it's called something totally normal that you just report out. So how many of you are doing gram stains with this, and how do you detect, or how do you even know that you're not working with something that's a BT type of an agent in your lab? Anyone? Go to the microphone. Anyone? Is this an issue, or is anybody concerned? I mean, we do seem to have reports every year where people have identified something on a MALDI and it's turned out to be a brucella, and then they have to deal with exposures or things in their laboratory. So does anyone have any tips to help others not have this happen?
I think this is pretty standard, but we're always doing our gram stains set up in the BSC and our oxidase and our very basic biochemicals to make sure that we're able to get it onto the MALDI. So before we're taking it out of the BSC, we're doing those things to kind of rule out.
Great. I've heard that people have given up doing a lot of gram staining, and so that was a concern that I had, is that potentially people just were spotting and running MALDI without doing the gram stain and then not knowing. So if you're doing your gram stains beforehand, that makes me feel much better as somebody who's concerned with biosafety in our labs.
Jahna, what is we do have, indicators for saying, no, wait, this could be a select agent, take it into the the biosafety cabinet. But do you know what they are offhand? No growth at 24 pinpoint, or there's some triggers there.
A lot of that ties into our blood cultures, especially because we have that gram stain offhand right away, and we can be like, oh, this is kind of small, or with respiratory specimens too, oh, there's a lot of diplococci in here, let's tape these ahead of time. But I think a lot of it comes down to, I think we're really good at examining the culture through the lid before we even get there. The kind of downside to that is that we do kind of require a preliminary overall culture gram stain to kind of guide us. If I were looking at a culture and it says I have a gram stain with numerous gram negative rods, but my McConkey's not growing anything, I'm going to start to think maybe I should be taking this somewhere else. So it's kind of
So it's I think what John is saying, correct if I'm wrong, is that it's a combination of having it in your protocol and teaching it, and then thinking critically about every culture. Is it meeting those criteria where you say, oh yeah. It's a fact of life when we're working in a BSL2 lab where so much of it's at the bench that, stuff happens every so often, you know, but to be aware, it's like, okay, I've only exposed one person instead of 5 people who kept working on that culture is, you know, maybe sometimes that's the best you can do.
So we have actually built, so we utilize Epic Beaker for our LIS, and we have built into our decision trees for each culture, if we have like a non-hemolytic large GPR or slow-growing GNR identified on our gram stain, we have a bioterrorism decision pathway that will lead us through essentially the steps outlined by WSLH and APHL, and it will, based on the biochemical results that are entered, lead you to like unable to rule out this organism, or we have a flag that will then come up if it's okay to MALDI, and then they know whether or not they can proceed with the MALDI or if we need to be sending this out to a reference laboratory or something.
I love that. Thank you. You made me very happy.
We do have something very similar to that, but it's on like paper printouts that are on every single bench. So we do have like a flow chart of what to look for and when you can decide that you're okay or not okay, but it's not built into our computer system.
All right, other questions, other issues with MALDI, things that are critical thinking skills that you really need to use when you're working with it? Okay, it looks like we're ready then to go on to the next one. Thank you, both of you, Tom and Jahna.